Hello, ladies and gentlemen. I hope you are all well. If I sound a bit odd, it's because I have a bit of a sinus going, but yeah, we go on. So, today we are going to talk about organic chemistry, but more about the basics. So, how do you name the compounds? Um, the functional groups and all of those things, only the basic stuff, okay, with a few examples with it. So first we need to know what is organic chemistry before we can just go into the things. So organic chemistry, it's basically just a study of carbon and hydrogen compounds, okay. So it has to do with carbon. As we know, everything living contains carbon. Okay, so it's also, you can also say it's the study of life. So if we look at the properties of carbon, we can see that it is high, that there is high catenation. Okay, so that means that there is chemical linkage onto the same molecule. Okay, so self-linking. And it depends on the type of bond. So here we can see there's a CC bond, so it's only one bond, okay. And then yeah, with the bond it's going to depend on the energy, okay. So if there's going to be a double or a triple bond, of course the energy is going to, there's going to be a stronger energy binding them together, okay, than a single bond. And then carbon can form a variety of chains. So if you look at this picture, there's this type of chain, and then it can form this type of chain. There's a lot of different types of things carbon can form, okay. So carbon can form also various ringed compounds. So you can see that there's those ones, there's a variety of rings that it can form, and it can bind with itself and with other atoms like heteroatoms, okay, like nitrogen, oxygen, phosphorus, and sulfur, etc. So here you can see in the picture that it bonds to nitrogen over there, oxygen, and sulfur. And when we go on, you're going to see with the different chemical functional groups, sorry, that it plays a role, okay. And then when we move to the nomenclature, sorry if I butcher that name, but when we move to this, now it's how to name the compounds, okay. So when we use met, okay, or meth, we say that there's only one, okay, it's only one carbon atom, okay. Eth, we say that there's two carbon atoms, so it can be, sorry, I could try my best to draw properly, but it's very hard with a mouse. So eth, it's two. Prop is if there's three, so prop is going to be an extra one like that, and then you get the hang of it. It's going to move on if it's more, okay. So four carbon atoms, you're going to use but. 5 you're going to use pent. 6 you're going to use hex. 7 hept. 8 oct. 9 is going to be non, and 10 is going to be dec, okay. So that is the number of carbon atoms in your chain, okay. Then you're going to use this nomenclature. So when we move to the naming of the compounds, the first thing you're gonna look for is the longest chain, okay. So you're gonna use the longest chain, and then of course you're gonna number it, but we'll get into it. So number 3 says that the numbering starts from the end, which puts the substituents or the functional groups at the end. And number 4 is if a functional group contains carbon, start numbering from that carbon. Okay, so how I understand it is, with the numbering you're going to start with the one that is the closest, okay, with the substituent group that is the closest, okay. So all the substituent groups, that's the closest. So when you look at number A, okay, they start numbering over here. So they start numbering 1, 2, 3, 4, 5, and then 6. Okay, so A is going to be the correct way. B is not going to be the correct way. So when you go this way, it's not correct. Okay, but try to think of it like you want to choose the side that has the most substituents. Okay, so you're going to start. So let's say we divide this one over there. Which side has the most substituents? It's going to be this side. All right, so we start on this side and then we count our way to the other side. Okay, so that's how I understand it. I hope it's a bit clear. So remember, you're going to start with the side that has the most substituents. Just remember that one. Okay, and the closest. Remember the closest one and the most substituents. Okay, then um, then we move to step 5. So you're gonna each substituent is denoted by putting a hyphen between the number and the name of the substituent. Okay, so you can see with this one, so it's 1, 2, and then there's going to be 3. Okay, so you put 2 hyphen methyl. Okay, and with the functional group you're going to put the ene. Okay, it's going to be the same. So remember, the important part is the hyphen. Okay, then if there is a presence of more than one identical group, okay, then you're gonna use these Greek numericals. So example, okay, let's say there's let's say there is a example like this. Okay, but we'll come to these examples at the end. But let's say there's something like this. Okay, so on one carbon you can see that there is 2 substituents. Okay, so there's 1 and number 2. So what you're going to use now, you're going to use that one, the di. Okay, so it's going to be 2 comma 2 hyphen dimethyl. Okay, so yeah, we're gonna use examples like this at the end, but yeah, just remember, so if there is more than one identical group on a carbon, then you can use these ones depending on how many there are. Okay, so 2 is going to be di, 3 is 3, 4 is tetra, 5 is penta, and 6 is hexa. Okay, and then where there is different substituents, the names are written in alphabetical order. Okay, so this is also another important thing to remember, alphabetical order. Okay, so here you can see when we see how they number, they moved from left to right. Okay, so you can see that the first, they chose the spot where to start, where the first substituent appears. Okay, so 1, 2, 3, 4, 5, and then this group, this one is a methyl group and this one is a ethyl group because it contains 2 carbons. Okay, 2 carbons. So then just remember in alphabetical order. So then it's going to be 3 ethyl, 2 methyl. Okay, and that's how to name the substituents. Okay, and then when different alkyl substituents are present at equivalent positions, numbering of the chain is done in such a manner that the alkyl groups comes first in alphabetical order, okay, at the lower number. So when you look at the example, you can see the correct way is at the bottom. Okay, so they started with the biggest group. So 1, 2, 3, and then 4, 5, 6. Okay, so functional groups. Okay, so there's a lot of functional groups. But let's start. Okay, so I see that we are missing one group, alkane. Okay, so let's just add alkane over here. Alkane. Okay, so alkane is going to be a single bond. Okay, so remember these ones that looks like this. Okay, this is alkanes. Okay, so they are single bonds. Okay, and their chemical formula is going to be CnH2n plus 2. Okay, when we move and the suffix, remember, we should just remember the suffix. It's going to be "-ane". Okay, so and then the next group is we have alkenes. Okay, so just remember the suffix is in the name is going to be "-ene". Okay, so it's in the name. It's double bonds. Okay, so like this. Okay, and the chemical formula for this one is going to be CnH2n. The next group we have alkyne. Okay, so the suffix is going to be in the name again, alkyne, and it's going to be triple bonds. Okay, example like this. Okay, and the chemical formula is going to be CnH2n minus 2. Okay, then of course you have these the ones that binds to the heteroatoms. So we call them halides. Okay, so those ones, they bind to the heteroatoms. Okay, like chloride or fluoride. Then we have alcohol. So the suffix is also going to be in the name, so it's going to be "-ol" for alcohol. Okay, the chemical formula is going to be CnH2n plus 1 OH. Okay, so remember, alcohol, they contain this OH group. Okay, so yeah, the OH group. Then we have the next group, we have ether. Okay, ether, the suffix for ether is going to be 8. Okay, 8. Okay, so yeah, that's an ether group. That is the chemical formula. Okay, so you can just remember this one. Okay, then aldehyde. Aldehyde, suffix for aldehyde is going to be "-al". So "-al". Okay, so that's an aldehyde group. So just try to remember the first one over there, "-al". Okay, the aldehyde group. And this is the chemical formula, but we can also say it's just RCHO. Next group we have ketone. So guess the suffix is in the name. It's going to be "-one". Okay, so for ketone, "-one". Okay, and there is the chemical formula or the functional group over there. We can also say it is RCOR. Okay, then the next one is the carboxylic acid group. Okay, carboxylic acid group, and its suffix is going to be a bit bigger, so it's going to be oic acid. Oic acid. Okay, yeah, it's also called a carboxyl group. Okay, and there is the chemical formula. We can also just say it is COOH. Okay, the next group we have ester. Okay, esters, and the suffix for esters is going to be 08. 08. Okay, and there is the chemical formula, or we can say RCOOR. Okay, and then there's the last group. You don't have to worry about the last one. And then we are not done yet, there's still more. So, but for this one, we're going to focus on amide. Okay, So the amide group, and the suffix is normally going to stay the same. It's going to be amide, and there is the chemical structure, and we can say it is RCONRR. Okay, so we can say that that is the chemical formula, and then this one you can ignore, and then we move to amine. So the amine group, now with amine it's gonna normally stay the same. Okay, and we can say the chemical formula is RNH2. So it depends on the type. Okay, so you can see we have primary amine, which is going to be this one. So okay, wait, let me just remove this, it looks nasty. Okay, so primary amine. Okay, so you see that there's nothing attached to it. Okay, so think of it like that, there's no legs. Okay, so with this example, secondary amine, so you can see here we have this thing, so it starts to get legs. Okay, so stick secondary amine with, and then we have tertiary amine, so it even has more legs. Okay, so 3 legs. So think of the primary, secondary and tertiary, think of legs. Okay, and then these groups, I don't think you have to worry about them, but just be safe and know them. Alright, then we go to examples. So the first example we have, I think what I'm gonna do is I'm gonna pause a bit, then you guys can figure out. Okay, and then I'll show the answer and explain. Okay, so let's start with this one. Let's start with number 1 over here. So I'm gonna pause a bit and then I'll explain. Okay, so what the answer for this one is going to be ethane. Okay, so let's start with numbering this chain. So we're going to start anywhere. We can start this side, 1 2, we can start 1 2. Okay, for this it doesn't matter because there's no substituent groups. Okay, so we said at the beginning we're going to use eth for 2. Okay, so 2 carbons, and we're going to use ane because this is an alkane group. Okay, so this is going to be ethane. Okay, so and then number 2. Okay, so the answer is going to be propane. Okay, so why do we say that? Again, let's start numbering. 1 2 3. Okay, you can start at that side or you can start at the other side. For these ones it doesn't matter because it's just a straight chain. Okay, but we will see how the numbering plays a role in the next example, but let's focus on this one for now. So there is 3 carbons, so it's pro, remember that one, the prefix, so pro, and again of prop, and ane is going to be because it is a alkane group. Okay, so propane. Okay, so these are easy examples. Then we're going to move to a harder example. So we have example number 2 over here. I'm going to give you a chance to figure it out. So that is the answer. So 2,2 dimethylbutane. Okay, so now the numbering starts. Okay, it plays a role. So we said we're going to start numbering where it which is the side which is going to be closest to the substituents, and in this case it's going to be the left side over here. Okay, so let's start numbering our carbon atoms. So we have 1 over there, 2, 3 and 4 over there. Okay, now when there is 2 carbon atoms or substituents on the same carbon atom, then we said we're going to use those Greek numerals, remember, so that's where the di comes in. Okay, so first 2,2, okay, because one substituent and substituent number 2. Okay, remember the hyphen, remember the hyphen. Okay, so 2,2 di, because there is two substituents, so that's di. Both of them are only one carbon. Okay, so one carbon, so it's a methyl group. Okay, so dimethyl. Okay, so it means two methyl groups. Okay, so that is sorted. Okay, and then but for 4 carbons in this main chain. Okay, and then ane because it's a alkane. Okay, so 2,2, remember your hyphen, dimethylbutane. Okay, then we have another one that's almost similar, but there's something special. Okay, then I'm gonna give you a few seconds to figure out. You can pause the video. Okay, so the answer to this one, so to example 3, is gonna be again 2,2 dimethyl bromopropane. Okay, so let's start numbering. Remember, we start the side where there is the closest and the most carbon substituents. Okay, so we start on again on the left hand side. So 1, 2, 3. Okay, so there is one and another one. So there's 2 methyl chains. Okay, so that's again where the 2,2 comes in, the dimethyl. Okay, so we understand that one. Then there comes this bromo part. Okay, so this bromo part, it is because of this hetero atom that joined, so the bromine. Okay, it joined, so that's why we have the bromo there. And then prop, because there is 3 atoms, and again ane because it is an alkane. Okay, then example number 4 looks like this. Don't be scared, but just pause the video, then I'll explain. Okay, so the answer to this one is going to be 4-methyl pent 1-ine. Okay, so let's start. Okay, so we're going to start with the closest functional group and substituents. Remember, the functional group is going to be this one over here. So we're not going to start on this side. We're not going to start here. We're going to start on this side. Okay, so 1, 2, 3, 4, 5. Okay, so there's 5. Then we have 4-methyl. Okay, because remember we're doing it in the order of the alphabet. Okay, so that's why this one starts first. Okay, so 4-methyl pent, because there is 5 carbon atoms. Okay, 1 is because at this carbon atom we have the first functional group, which is an ine. Okay, alkyne. That's why we have that one, because it's an alkyne. Okay, so 4-methyl pent 1-ine. Okay, I hope you guys understand. Then we have one more example, which is going to be this one. Then I'm gonna give you a chance to pause the video. So the answer for this one is going to be 3-bromo 2-methyl pentane. Okay, so don't freak out. Okay, so for this one, remember, so we're going to start with the closest substituents and functional groups. So in this case, we're going to start on this side because we have this one over here and not on this side. Okay, so 1, 2, 3, 4, 5. So the 2, okay, remember your in alphabetical order. Okay, so B is going to be first, of course, in the alphabetical order. So it's going to be 3, remember your hyphen, promo, then again hyphen 2 for this carbon over here, methyl because it's only one carbon, then pent because there is 5 carbons in the chain, in the longest chain, which is this one, and then ane for alkane. Okay, so we're back to alkane. Yeah, so that is the last example. Okay, so I do recommend you using this book, this organic chemistry, because there's like little exercises inside where you can practice the suffixes and the nomenclature and all of those things. Okay, so to familiarize yourself with the organic chemistry. The answers, they are at the back of the book, so I did check, so you will find your answers at the back. Okay, so but I do recommend going through this. It's going to make it much easier. The references, I just put the front pages of the books like this, so it's easier to recognize for you when you decide to download them yourself. But I did upload them on the Google Drive. All right, so when you go to the YouTube channel and you click on this about, okay, this about button over here, this tab, and you click on this link over here, it's gonna take you to all the electronic resources that I talked about in the first video, if you guys remember. Okay, so it's gonna take you to the Google Drive, and I did upload them. There's evidence, so the books are there. Okay, and yeah, that is all from me. Thank you for watching, and if it was helpful and you enjoyed, please leave a like. Thank you. Bye bye.